Now let's look at factoring the difference of two squares. So first let's think about what we mean by difference of two squares. What we mean is when you have something that looks like a squared minus b squared. For example, if you have x squared minus 36. Well, it turns out that whenever you have something which is written a squared minus b squared, then it can always be factored a plus b, a minus b. And it's just the opposite of FOILing here. So let's first just write this out. X squared is a square, and the square root is x. And 36 is a square, and the square root is 6. So this will be x plus 6 and x minus 6. And if we're not sure about that, what we can do is we can turn around and FOIL it. F-O. Right? That's x times x is x squared, and x times minus 6 is minus 6x. And inside, 6 times x is 6x, and then last is 6 times minus 6, that's minus 36. So that's x squared minus 6x plus 6x, but the minus 6x and the plus 6x cancel, and you get x squared minus 36. And that's the reason that difference of two squares works, is because when you multiply x plus 6, x minus 6, the middle two terms cancel each other out. So let's look at a couple of examples. Let's factor the following. Let's factor x squared minus 49. So the first thing we have to do is see, is this the difference of two squares? Is x squared a square? Yes. Is 49 a square? Yes. Are they separated by a negative sign? Yes. So this is going to be the difference of two squares, and it's going to be factored to x plus 7, x minus 7, where you simply have the first term is the square root of the first term, and the second term here is the square root of the 49. So let's do another one. Let's factor x squared minus 121. That will factor into x plus 11, x minus 11. And finally, let's factor x squared plus, let's do 64. So is x squared a square? Yes. 64 a square? Yes, that's 8 times 8. But they're connected with a plus sign, so this you can't factor this. This is not the difference of two squares. And because of that, you can't factor, at least not the way that we do it here. So there's a couple of other important questions that we need to look at. The first one is, what if we had something like this? Let's say it was factor 9x squared minus 121. Well, that's going to work as well, because if you look at, let's look at this first term, 9x squared. Is that a perfect square? It turns out it is. That 9x squared is simply 3x times 3x. So that's going to be 3x and 3x. Now, 121, is that a square? Sure. That's 11 and 11, and they're separated by a minus sign. That means you have 1 plus and 1 minus. Another typical problem. We have 16x to the 4th minus 49y squared. 16x4, is that a square? It turns out it is. It's just 4x squared squared. 49y squared, is that a perfect square? It is. It turns out it's just 7y squared, and they're separated by a minus sign. They are. So remember, this is the rule. A squared minus b squared is simply a plus b, a minus b. And as long as this pattern holds, it doesn't matter how complicated a and b are. In this case, a squared is 16x to the 4th, so a is going to be 4x squared. B squared is going to be 49y squared, so that's just 7y, so that's plus 7y. And then it's 4x squared minus 7y. And that's how you factor the difference of two squares. I want to show you one last problem, and that is sometimes you have to factor a monomial out before you go further. So let's do this. Let's say we had factor 3x x to the third minus 75x. Well, that's not the difference of two squares. 75 is not a perfect square, and 3 is not a perfect square. But what we can do is we can factor 3x out. And if we factor 3x out, then what we're going to do is we're going to divide everything by 3x. The 3's cancel, that becomes x squared. The x's cancel, that becomes 75 divided by 3, that's going to be 25. And then x squared minus 25, that's the difference of two squares. So your final answer is going to be 3x times x plus 5, x minus 5. And that's how you do the factoring of difference of two squares.